is Jaya Venkata Rama Reddy, Data Science Intern at AVISHKAR. This is an ML model based on Pima Indian's diabetes dataset. This dataset contains the information about women with diabetes. As we can see, this diabetes dataset contains columns like number of times pregnant, glucose concentration, diastolic blood pressure, tricep skin fold thickness, 2-hour serum, insulin, body mass index, diabetes pedigree function, age, and at last a class variable. This class variable says whether the patient has diabetes or not. As simple as that, because we can see that 1 means that the patient is diabetic and 0 means the patient is not diabetic. Now coming on to the code, starting I imported all the packages which I need for building the model, and then I read the CSV file and stored in DF, and then I printed the DF. Now I split the DF into train dataset and test dataset. This is the correlation of DF. The correlation graph gives the correlation of a particular column with each and every other column in the dataset. As you can see, plasma glucose concentration has highest correlation with the class variable, and in the same way, diastolic blood pressure has the least correlation with the class variable. Next, I printed the number of zeros in the DF dataset, as you can see, and I printed the number of zeros in training dataset and testing dataset. Now, using for loop, I tried to replace zeros with null. In the features list, I stored all the columns with zeros except the number of pregnancies, because 0 pregnancies is not a wrong value. Then I replaced them with null, and now I printed the number of zeros and nulls. We can see that. Now over here, I replaced all the null values with median according to their output. Over here in this cell, I did that for plasma glucose concentration, and in this cell for diastolic blood pressure, tricep skin fold thickness, for 2-hour serum insulin, and body mass index. These are the values, these are median values with which I replaced zeros. I printed them over here, as you can see. Here. And next, this is the number of nulls. So we can see that there are no null values, and as well as there are no zero values. From here, there is the correlation graph of the training dataset. If we observe in this correlation graph, we can see that plasma glucose concentration has the highest correlation with class variable, and in the same way, diabetes pedigree function has the least correlation with the class variable after replacing zeros. Now I created X and Y data set. X contains training data set without class variable, and Y contains training data only class variable of training data set. Now again, I divide X and Y into X train, Y train, X test, and Y test. As you can see, I imported random forest classifier, and I printed accuracy, and it turned out to be 90%. And over here, using cross-val score, I calculated mean for accuracy and recall with k equal to 10 folds. As you can see, the accuracy mean turned out to be 87%, and the recall mean turned out to be 80%. And over here, I imported KNN classifier and recall correlation score. As you can see here, I imported cross-validate, and the values for accuracy and recall and precision using cross-validate are 86.78%, 82.73%, and 81.25%. And then I was seeing for skewness in both train and test dataset, and these are the skewness values, as you can see in both train and test. And then in the data list, I have stored all the column names except the output variable, which is class variable. And using for loop, I tried to remove the skewness with log transformation. Means if the skewness of the particular column is greater than 0.3, I did log transformation for both test and train. Then if you see number of times pregnant column, there are minus sign values, so I dropped number of times pregnant column from both train and test. Then I divided training dataset into X log and Y log. Then I divided X log and Y log into X train log, Y train log, and X test log and Y test log. And again, using random forest classifier, I checked accuracy, and it turned out to be 88%, and recall and accuracy using cross-valid, and they turned out to be 86 and 82%, and precision and recall for the particular testing, and it turned out to be 79% and 87%. Then I imported XGBoost, and this is the classifier for XGBoost, and these are the parameters for XGBoost. As you can see, I applied random search CV for XGBoost parameters, and I found the best parameters. And the best parameters I copied them and I pasted them in the classifiers section over here. These were the best parameters. When I ran that, I got these parameters and I copied them over here. Using these parameters, I tried to classify. This is the classifier thing. So using cross validation score, I got the accuracy as 88%, mean accuracy is 88%, and the mean recall is 81%, and the particular accuracy for the testing dataset is 90%. And I imported confusion matrix, and the confusion matrix turned out to be this, and the number of correctly predicted to 97 and 42 values, and the wrong was just 15 values, and the precision is 82%, and the recall was 87%, as you can see over here for the particular test dataset. Then I imported pickle and I dumped and opened the pickle file, log_model.pickle, and you can see I tried to predict the outcome for these values. I created a data frame using those values, and yeah, I tried to predict, and it turned out to be the person don't have any diabetes. And I took another set of inputs and I did it, and then did the same thing prediction, and it turned out to be that the person have diabetes. So this model is deployed on Django, deployed using Django software. Let's see the web interface of the project. This is the web interface of the project. Let's give out some input values for checking the prediction. Let's see, just 35. Yeah. Submit, and yeah, it turned out that the person is not diabetic. If you can, as we can see, the diabetes prediction is no. Let's give another set of inputs now, and let's see what will be the output. So the skin thickness is 28.1, insulin is 199. Let's give it as 199. So 0.5, and age is same as before, 35. Yeah, now the diabetes prediction turned out to be yes, as you can see over there. So thank you for everyone who supported me and made this project successful. Thanks for the AVISHKAR team, and mainly my mentors, Mr. Sir, Sushma ma'am,